Is this reality? Well, we're experiencing something right now. So maybe the better question is, what is reality? Could everything we see, everything we experience, everything that exists in our entire universe be artificial? Supporters of simulation theory believe that not only is it possible that we're living in a simulation, it's likely. And the more we look for evidence, the more we find. Let's find out why. The idea of the universe being a simulation is not a new one. Theories exist in ancient cultures around the world. Modern simulation theory comes from Nick Bostrom, a philosopher at Oxford who wrote an influential paper on the subject in 2003, assuming that living in a simulation is possible. Bostrom presents the simulation trilemma, which says, one of the following must be true. 1. We destroy ourselves before we're able to create a simulation. 2. We're able to create a simulation, but choose not to. Or 3. We are definitely in a simulation. Bostra believes each of these is equally likely to be true. Now, I don't think that's controversial. We use computer models to study the human population, predict the weather for entertainment. We simulate everything. And when a civilization can create a realistic simulation, the most obvious one to create is that of its own early existence. Bostrom calls this an ancestral simulation, and a civilization that can do this wouldn't just create one simulation, it would create many, and those simulated civilizations might create their own simulations of the universe and on, like Russian nesting dolls of reality.
Now you're a character in that world and you think you have free will and you say, I want to invent a computer, so you do. Hey, I want to create a world in my computer. And then that world creates a world in its computer. And then you have simulations all the way down.
When Elon Musk was asked what he thought the chances were that our reality is the original base reality,
Odds that we're in base reality is 1 in billions.
Neil deGrasse Tyson is a little more conservative. He thinks the odds that we are in base reality versus a simulated reality is 50-50, a 50-50 chance that everything we experience is artificial. That's still pretty high. And even though we mostly hear what scientists think about this, it's not scientific. Theory. Simulation theory isn't math, it's philosophy. It isn't physics, it's metaphysics. So what we need is hard evidence that we live in a simulation. And to find proof, all you have to do is look. One way other realities blended to ours could be the Mandela Effect. The Mandela Effect is when a large number of people have memories of events that don't match reality. This is called the Mandela Effect because millions of people specifically remember Nelson Mandela died in prison. He didn't. People remember his wife walking beside his casket in a funeral procession that was on television for 2 hours that day. This never happened. Or the Batayan Bears, which people insist were always called the Best Ein Bears. The evil queen from Snow White, who looked into her mirror and said, "Mirror, mirror on the wall." Nope. Magic mirror on the wall. Who is the fairest one of all? That's the Mandela Effect. So why do millions of people distinctly remember different things glitch in a simulation? Yep, Philip K. Dick also felt. When we experience déjà vu is because something in our simulated universe changed and a new timeline branched off of the current one.
We are living in a computer-programmed reality, and the only clue we have to it is when some variable is changed.
Ever feel like you've lived a moment before? That's because, according to Philip K. Dick and others, you have déjà vu as the simulation correcting itself with new information. But skeptics can easily dismiss these theories. The human mind is terribly unreliable. They don't accept this as evidence, but we're not done yet. We live in a huge universe, 200 billion trillion stars, and even if life is rare, you'd think there'd be some evidence of it somewhere. This is Fermi's paradox, but according to the Drake equation, there should be over 1 million technologically advanced civilizations just in our galaxy, and on average, the nearest one should be just a few 100 light-year away. But there's nothing, at least, not that we can see. So where is everybody? Are we really alone in the universe, or does our program only focus on us? And what about the physical rules that are in place? Max Tegmark, a cosmologist at MIT, said, "The strict laws of physics point to the possibility of a simulation putting a cap on the speed of light." Sure, is a good way to keep your Sims from venturing out too far from home. Theoretical physicist James Gates thought simulation theory was crazy. Then he started studying quarks and electrons. He found error-correcting code buried deep inside the equations used to describe string theory.
So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos.
Into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
Dr. Gates has changed his mind about simulation theory. In 2017, a group of scientists at the University of Washington proved they can embed computer code into strands of DNA. Everything in nature is math. Look at the Fibonacci sequence. You get the Fibonacci sequence by adding two previous numbers in the sequence together. So 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, and so on. Forever, you get the golden ratio, also called PHE, by dividing two consecutive Fibonacci numbers. So the number 89 is a Fibonacci number. The next number in the sequence after 89 is 100, and 100, and 44 divided by 89 is the golden ratio. It's about 1.618. We see Fibonacci numbers and the golden ratio everywhere. The number of petals on a flower is usually a Fibonacci number. Lilies have 3 petals, buttercups have 5, chicory has 21, and a daisy has 34, and the spacing of each petal is arranged in a circle according to the golden ratio. As trees grow, the number of branches they form is a Fibonacci number, and not just plants, animals too. The ratio of female tamale honeybees in a colony is the golden ratio 1.618. The human body conforms to the golden ratio 2. Most of the body follows the numbers 1, 2, 3, and 5, 1 nose, 2 eyes, 3 limb segments, 5 fingers, 5 toes. The proportions of the body, like the length of your shoulder to your elbow and from your elbow to your fingertips. That's the golden ratio. Even a DNA molecule measures 34 angstroms long by 21 angstroms wide. Fibonacci numbers and the golden ratio. From the spiral of seashells to the spiral of a galaxy and everything in between, Fibonacci numbers are everywhere now. Some claim this is a coincidence. The humans look for patterns in chaos because that's what we're programmed to do. It isn't that interesting. By trying to debunk simulation theory, they actually end up proving it no matter what we study. Whether it's something the size of a galaxy or as small as an electron, everything in the universe seems to follow patterns and rules. In other words, a program. To simulate an entire universe, you'd obviously need more advanced technology than we have, but that doesn't mean we won't get there. Moore's law says that computing power doubles every 18 months, and this has held true for about 50 years now. That is slowing down a little bit, but only because of physical limitations. Assuming we can learn to make micro smaller, and there's no doubt that we will, it's predicted that artificial intelligence could surpass human intelligence within the next 100 years. As Elon Musk points out, when he was a kid, the world's most advanced video game was Pog. 2 rectangles on a screen 40 years later. Video game technology is barely distinguishable from reality. He said that 6 years ago. And even in that short time, video game engines have become even more realistic.
When a world we can build feels as real as our own.
What just happened?
Supporters of simulation theory often point to video games as a way to explain, if not prove, that our reality is artificial. In a video game, the only data that is rendered is what the player sees or interacts with. If you're playing a video game and there's a car or building a mile away, that entire object isn't rendered. The game engine only renders the bare minimum of information to make the object look real. A distant building is rendered as just a few pixels, not that complicated. As you get closer, the engine renders more details. But still, it's just a facade. The engine doesn't bother calculating what's inside the building to actually go in. The game engine always knows how much data to send you and doesn't bother with anything else. If we live in a simulation, it would make sense that our reality is rendered the same way, and we could test this. Specifically, we can use the double slit experiment. Here's how it goes. If we fire particles in a straight line at a screen after passing through a single slit, we would expect to see this clumping pattern on the screen. Expect to see a pattern like this where particles are most dense in the middle of the screen, but radiate outward similar to the clumping pattern. When we add a second slit, it starts to get fun. When the waves pass through the double slit, each slit creates its own wave. When those waves intersect, they cancel each other out. That creates a pattern like this. It's called an interference pattern. So particles passing through two slits create clumping patterns. Waves through two slits creates an interference pattern. If we fire electrons through the slit, we see the clumping pattern as expected. An electron has mass, so it's a tiny bit of matter. So if we fire electrons through two splits, we should see two clumps, but we don't. For years, scientists assumed that the electrons were colliding with each other, causing the wave pattern. But in the 60s, the experiment was modified so that only one electron at a time was fired through the slits. There was no way the electrons could interact with each other, yet we still see an interference pattern. Scientists wanted to see what was causing this, so they added a detector to observe electrons as they pass through the slits. That's when things go from weird to paranormal. As soon as the detectors were installed, the interference pattern went away and the clumping pattern returned. Take the detectors away, and the wave interference pattern is back.
But that's a different result to what we had earlier. So here's the last bit of sneakiness that we can play with atoms. Surely now, we're going to get to grips with it. Leave the detector there, but just very quietly go and unplug it. Don't let the atoms know that you're not spying on them. Run the experiment again. Now, if you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you.
Galaxies may not actually be there. If we're living in a simulation, then stars and galaxies could simply be projections, and only when we get up close, when those projections become more detailed. This is an excellent way to save computational resources, and because we're stuck with the hard limit of the speed of light, getting to far-off places is really difficult. Limiting the speed of light is a useful rule to have in place quantum mechanics like the doubles experiment and quantum entanglement only. Be safe, be kind, and know that you are appreciated.